Hello, let me just show you our OneNote. So MathMech Plus, I'll be using a OneNote digital tablet learning station with students. This is GCSE or iGCSE. So let's have a look. I'll go through each strand and pick out maybe two or three lessons just to demonstrate the scaffolding, the AFL, the real life application that I'll be showing, and how I want students to remain curious, to make connections, to see patterns, so that it can help them in their future career in mathematical sciences, in science, in IT, in engineering, finance, or beyond. Okay, coordinate geometry. So in some topics I'll have a list of the learning objectives, some others I will not. So you have some exam questions, obviously. There will be exam style exam questions, but I try also to have it scaffolded in a way that will invite the curiosity, as I said, that students can make their own connections as well. Otherwise, it's just a little bit dry. We'll just quickly go on, just pick differentiation. So for instance, I have here a short history little lesson with Isaac Newton and Gottfried and Leibniz. They both, we'll get into it, they both invented calculus in 1665 or something like that. And differentiation is the start of the introduction to the GCSE of calculus. And we'll talk about what that is before we start getting into questions. So we have like real life examples of questions as well. Here we have kind of a business studies example and so on. So we'll just keep moving on just to show the different strands. Transformations, as you see here, students have been doing this since grade 6. So what more do they need? It depends on what they've remembered, of course, and what they retained. But the characteristics, the information that they must include, we focus on that kind of aspects when we're doing exam questions. I'll pick one more, volume of cones. So again, formula-based questions that can be quite expansive actually, especially the end of paper kind of questions, the difficult ones. Do they need to learn off formula? I'm not really interested. I think that maths is to be practiced, not really for learning. When we go to history class, we learn key dates and events of a bygone era. For maths, we just practice it. And by practicing it and understanding the how and the why of the formula, students will be able to apply it. And this whole rote memorization is not so necessary. I know students sometimes just like to learn off the quadratic equation, maybe, and things like that. The quadratic formula, I should say. We just keep moving on. So that kind of idea is what I'm trying to engage with here. Statistics. So for instance, we might have a discussion chain. So skewness is a topic that sometimes students avoid, about spread of data and the quartiles that you see here. So we'd have a little discussion about it, a little brainstorming session to make sure that everyone understands why we use it and where it's applied. Okay, histograms. So here's an example of real life, well, photographs. Photographs use histograms in this context, if you've ever seen that in a digital camera. And there'll be questions on probability and the other aspects of statistics that we see in grade 10, grade 9, grade 10. Algebra, another expansive, a lot of topics here. So just the roots. So we can make questions on that. We have it scaffolded in a way that students can get on with it. From a kind of a medium to challenging flight plan, we'll say. Solving equations, same kind of idea. So they have the step-by-step processes and stuff. If they need hints, and they'll work through the ideas. And this is obviously just the lesson in a sense. And they would have worksheets and things otherwise. So I've MathMech created for that as well. Number patterns, there are sequences students know. Of course, there are formulas here too. So we try and apply it in such a way that students can understand why and how we use that formula instead of learning off a whole proof. For instance, Pythagoras. So trigonometry, what does it mean? I would think 3D Pythagoras, 3D trigonometry. There's lots of stuff. There are larger angles, so the obtuse angles for sine, cosine, tan, and so I have lots of pictorials and things, and ideas like that were needed, I suppose, or were applicable. So that's that. I suppose just the last one on GCSE, number. And you'll notice, for instance, I don't have decimals or fractions here. I've picked out the kind of more challenging aspects, and I haven't included the mixed style questions yet. Of course, that'll be more an isolated thing when we do the exam questions and exam style stuff. But it's important to see things and to learn things individually, and then you can put it together. You can build a bigger picture, so to speak, with the content, with the skills, with the knowledge that you've learned. That was GCSE. A quick look at AS level that I have here. Quadratics is where we start off, completing the square. So completing the square, for instance, just to pick out one or two, can be very difficult for a lot of students. They're not really sure why they use it. That's often what happens. The rewriting of a quadratic expression. And that's an important part that I want to feel it for students. It's just the function of just understanding why we're actually doing something, and to talk about it, and to make sure they understand the key words, the applicability, and where basically it continues on to be used in future years. So quadratics, there's a lot of parts here. For the AS level, you'll have 7 or 8 parts to each unit, so there's 9 units. Positive, negative, so just sketchy graphs. I'll just keep moving on. Functions are a very important part that you'll do in your university maths as well. And I have it all set out there, so functions and transformations of them and so on. Coordinates, what we got? Coordinate geometry, so we don't have Newton. This is René Descartes. Cartesian coordinates are those X and Y things that you might have remembered. I'll just call it the X and Y grid. And we go through all those aspects and seeing why we do this, and it becomes understood in a general, in a more broader sense, why students actually do these things, and it's not just formulas for their own sake. Equation of the line, equation of a circle, and you just keep moving. Circular, so the history of radians is actually quite interesting. Degrees even, back to Babylonian times and so on. Trig identity, so after this there's sequences and series, so like the sequences of grade 10, and calculus, which is differentiation and integration. So that's in a not so expansive way, just a little tour of the OneNote that we'll be using for digital tablets in MathMech Plus. Okay, thank you.